In the future, it may be possible to make robots so tiny you can't even see them. We're not there yet, but we're getting pretty close. Here are the top 10 incredible micro-robots. Number 10. Microscallops. Robots are generally powered by electricity and require complex motors to move. But when it comes to developing microscopic robots, that might not work out so well. One special robot, however, bypasses such limitations. These microscallops can swim through bodily fluids and even into your eyes. Rather than electricity, they are powered by an external magnetic field. These robots are being developed to deliver drugs to places that can't be reached by human hands. Talk about the future of medicine. Number 9. Black Hornet spy drones. In the near future, the United States Army plans to equip nearly all of its combat troops with tiny drones that can spy on enemy forces from the sky. These drones are known as Black Hornets and are small enough to fit in one hand. These Black Hornets can fly over 13 miles per hour and can take HD photos and live video. They have the potential to change the world's militaries as they provide unmanned security for military soldiers. Number 8. Zuda Pocket Printer. While most of the robots on this list have more serious applications such as medical breakthroughs or military spies, this small robot is a bit more for convenience or even novelty. If you're an office geek, the Zuda Mini Mobile Robotic Printer will surely make it to the top of your wish list. Beginning on Kickstarter, the Pocket Printer weighs just 350 grams and has a diameter of only 10 centimeters. While most printers take up at least a square foot of space on your desk, this one will fit in your hoodie pocket. This tiny printer has a battery that'll last about an hour, and it's going to need it. It takes about a minute just to print one page because it prints slowly, gliding across the page. While the printer is not yet on the market, it has entered production after its successful campaign on Kickstarter. Number 7. Cyborg Beetle. While it's not technically a robot, this creation is an incredible example of scientific ingenuity. Popularly known as the Cyborg Beetle Project, a man named Hirotaka Sato from Nanyang Technical University in Singapore and his colleagues have combined electronics with live beetles to allow the beetles to be remote controlled by humans. By implanting 6 electrodes into the beetle's wing muscles and powering them with a lithium battery, scientists have harnessed control of this beetle's flight. Not only can they control which direction the beetle flies in, but they can also make it land, take off, or hover in place. Should this technology be developed further, its uses are boundless. It could be used for exploration, espionage, or even communication by the attachment of small microphones. Beetles are the perfect insect for the project. Because they are relatively strong, it's easier to attach electronics and sensors without weighing them down. Number 6. RoboBee. After 12 years of research, Harvard scientists were able to create a tiny flying robot known as RoboBee. RoboBee isn't any normal micro-robot or insect-like drone. RoboBee was one of the first robots to achieve flight. With a wingspan of only 3 centimeters, RoboBee is the smallest insect-like robot that can fly. That's not all. RoboBee solved 2 previously unconquerable challenges that come with micro-robots. First, RoboBee was built through a process that was inspired by pop-up books that allows engineers to build on such a tiny scale. Second, to be able to fly, RoboBee contains man-made muscles that beat its wings 120 times per second. The aim of RoboBee is to eventually develop a fully autonomous swarm of flying insect robots. Theories for its applications vary greatly, from search and rescue missions to crop pollination. The greatest challenges with the development of RoboBee, however, are supplying power and decision-making capabilities. Currently, RoboBee is connected to a small tether that supplies its power and allows someone to control it. To reach its goals, the development of RoboBee has been divided into 3 categories: brain, body, and colony. Development of the brain consists of dealing with RoboBee's sensors, electronics, and ability to mimic insect behavior without a human controlling it. Body development consists of RoboBee's physical construction and engineering, including its ability to fly. Finally, colony development emphasizes RoboBee's ability to function in a full swarm of RoboBees, with each one behaving for the benefit of the swarm. Number 5. RoboFly. The idea of robots the size of insects brings optimism to many people from many industries. Whether it's spying on enemy soldiers or inspecting crops on a farm, the possibilities are endless. But insect-like robots are not easy to engineer. Because insect robots have such tiny wings, it's very limiting on how heavy the electronics can be. Hence, why RoboBee needed a small tether. Fortunately, a group of engineers from the University of Washington, including one who also worked on RoboBee, has also developed an untethered flying robotic insect. Known as RoboFly, this machine weighs about as much as a toothpick. How does it work without a tether sending power to it? A laser beam. The minuscule circuit attached to its body converts energy from a laser beam into the electricity it needs to power itself. To give it an extra boost, a specially designed circuit and photovoltaic cell provide up to 240 volts to power its wings. But its energy source isn't the only thing that makes this insect superior to RoboBee. Unlike RoboBee, which also relied on its tether to be controlled by humans, RoboFly has been provided a brain. This specialized brain mimics the brain of a real fly and tells its wing muscles when to flap. A more sophisticated successor to RoboBee, RoboFly is the future of micro-robots. In the near future, RoboFly will be given superior brains that will bring it closer to fulfilling the dream of a self-determining, swarming insect robot. Number 4. Ant-sized microbots. Considering these robots are only about 2 millimeters long, barely the size of an ant, battery power is out of the question. These so-called micro-bristlebots are instead powered by tiny vibrations delivered via ultrasound, a vibrating surface, or even a small speaker. Developed by robotic engineers at Georgia Tech, these microbots are made out of 3D printed polymer resin. Each robot has a number of bristles that act as its legs. Resting on the back of each robot is an electric actuator or operation device. When vibrations are administered to the microbots, their slanted bristle legs move up and down, allowing the robots to move around. The actuators on their backs are also capable of providing vibration to the legs, but considering the size of the robots, it's difficult to fit a power source onto the actuator. The microbots developers hope to employ electric fields to power the actuators in the near future. The speed at which these robots move is determined by the amount of vibrations being sent through them. And by modifying a microbot's leg size and other aspects, the bots can be changed to react differently based on the frequency of the vibrations. Researchers theorize that by conjoining two microbots with different physical designs, they may be able to control the robots by manipulating the vibrations to each side. One of the most ambitious hopes for these robots is to use this simple but impressive technology to move throughout the human body, probably for medical purposes. Number 3. Piccolissimo. Speaking of the world's smallest robots, one of them is so tiny that it contains only 2 moving parts. While big, flying machines like helicopters are great for transporting people or objects, micro-robots require just as much genius as far as engineering goes. One tiny robot developed at the University of Pennsylvania is easily one of the most sophisticated. Its name is Piccolissimo, which has a double meaning. Piccolissimo is the Italian word for smallest, but Piccolissimo is also named after its inventor, Matt Piccoli. While there are many robots that are smaller than Piccolissimo, it still holds the title of being the smallest self-powered and controllable flying robot in the world. No other tiny robot is as powerful as or able to be driven like this tiny flyer. But just how tiny is the University of Pennsylvania's little creation? It's only about the size of a quarter, and it's made up of just 2 moving parts. One of them is the propeller, which spins rapidly and a little off-center. The other is the robot's 3D printed body section, which also spins at about 40 rotations per second. The tiny robot maneuvers around by small changes in the body's spin speed, allowing it to move in different directions. The robot is steered by an infrared signal controller. As of now, the robot's sole function is flight. However, it was designed to be modified for countless functions. But considering the robot's size and weight, additional functions would need to be kept small and light, as the robot's maximum load is a mere gram. Matt Piccoli has mentioned the ability to add code scanner cameras. Piccolissimo also has the potential for practical applications. While it's an extremely small and relatively simple machine, that's what makes this robot perfect for several jobs. Because it doesn't require any complex computing or expensive technology, Piccolissimo is also cheap and somewhat disposable. Rather than sending in an intricate and costly robot to investigate some sort of theoretical problem, this robot can be sent in with minimal loss if it fails or gets damaged. Number 2. Robotic pill. When thinking about a future where robots are commonplace and heavily integrated into our society, most people tend to think of robot soldiers or butlers. However, one of the most common uses of robots currently in development is for medical purposes. When taking medicine, there aren't many people who would rather take an injection over swallowing a pill. Unfortunately, there are many drugs that can't simply be swallowed and need to be injected. One of the most well-known of these is insulin, but one medicine company has found a solution. Located in San Jose, California, Rani Therapeutics is a biotherapeutics company that has created a robotic pill designed to save people from having to take shots. The reason drugs such as insulin can't be taken orally is because the human digestive system will quickly break the drug down before it has a chance to work. This robotic pill, known as the Rani pill, is a normal-sized pill armed with a tiny needle. Once it enters the stomach, the robot aligns itself with the intestinal wall and injects the drug. The procedure is painless as the stomach wall does not contain pain receptors. While testing of this robotic pill has shown absolute success in animals, it's difficult to get clinical feedback from animals because they can't tell you what they feel. But the Clinical Research Organization in Texas has conducted human testing of the Rani pill. The test was conducted on 2 groups of subjects, one group that took the pill after eating and another group that took the pill on an empty stomach. Each subject took an empty Rani pill to test the viability of the device without any drugs. Using X-rays to track the robotic pills, the device proved safe and painless for both groups of patients. Test subjects reported feeling nothing even when the pill needle pricked their stomach walls. There were no side effects. Rani Therapeutics hopes that this combined feat of engineering and biochemistry will bring a better quality of life to people across the world. On average, a patient with type 1 diabetes and no insulin pump will have to stick a needle into themselves between 700 and 1,000 times per year. The successful development of the Rani pill would save these patients a lot of pain. If the drug-filled tests are completely successful, we may be seeing more of these robotic pills in the near future. Honorable Mention 1. Kilobot. To some, 1,000 tiny robots running around in a swarm might be a futuristic fantasy, but to many, it sounds just as terrifying as a swarm of cockroaches. Around 2011, a group of roboticists from Harvard University developed a small unit of about 25 robots. By 2015, they had over 1,000. These kilobots are tiny robots created by Harvard researchers Radhika Nagpal and Michael Rubenstein. They stand less than 3.5 centimeters tall and are swarm robots. Swarm robots are a classification of robots designed as multiple individual robots that work together as part of a singular system. A popular example of this at work is in coordinated drone displays, such as the one presented at Lady Gaga's Super Bowl performance in 2017. Although these robots are called kilobots, they aren't armed with any dangerous weaponry. In fact, kilobots are completely harmless. Each one costs less than $14 to build. The robots move around by vibrations sent through their legs. They communicate with the rest of the swarm through infrared transmissions. While each robot does little more than wiggle around, sometimes messing up or breaking down, when you have over 1,000, the collective swarm will succeed. In dealing with swarm robotics, most developers stick with constructing the robots digitally using 3D modeling and simulation software. Before these Harvard researchers built their miniature army, most roboticists wouldn't have dared to spend resources on building non-digital creations. What do these robots do? As of now, their most developed skill is self-assembly. By communicating with each other, the robots are able to organize themselves into various shapes, such as a starfish. But many believe that these kinds of robots can be used to better understand natural behavior, such as in schools of fish or even humans. Honorable Mention 2. Blood cleaning robots. If someone announced 30 years ago that they were creating intelligent robots small enough to swim through your human blood veins, they would have been called crazy. But in this technological era, scientists have made unbelievable discoveries time and time again. Roboticists at the University of California, San Diego have created microscopic robots that have the ability to cleanse human blood of bacterial pollutants from the inside. These machines, referred to as cell-like nanorobots, are powered by ultrasound and are able to swim through blood to remove bacteria and their toxins. Each nanobot is about 25 times smaller than the width of a single strand of hair and swims at a rate of 35 micrometers per second. The nanorobots are built by combining gold nanowires with the membranes of human blood cells and platelets. The hybrid membrane coating gives the nanorobots the benefits of 2 different kinds of cells: red blood cells, which counteract the toxins generated by bacteria, and platelets, which limit pathogens. As an added benefit, the membrane coating also shields the nanorobots from biofouling, a bodily defense mechanism during which proteins cling onto foreign objects to prevent them from harming the body. While these nanorobots are still in development, researchers are hopeful that the technology could be monumental in the field of medicine. During clinical testing, blood samples polluted by a type of bacteria called MRSA were treated with nanorobots. Within 5 minutes, the samples contained 3 times less bacteria. According to researchers in charge of the cell-sized nanorobots, the end goal is not only to use them to treat MRSA bacterial infections, but also to cleanse biological fluids in general. The researchers also intend to perform tests on animals and craft the nanowires found within the membranes out of biodegradable materials rather than gold. Number 1. Cell-sized nanobots. The researchers from California, however, are not the only ones who have engineered nanorobots. A group of scientists at MIT has created robots just as small and much more complex. The nanorobots from MIT are the same size as a human egg cell. They are made up of two-dimensional electronic circuits attached to tiny particles called colloids. A colloid is a mixture, or the particles in a mixture, that cannot be dissolved, so they remain floating throughout a substance. By combining nanorobotic technology with colloids, the researchers aim to develop robots that can move through substances to perform diagnostics. While medical researchers hope to send these nanobots through the human bloodstream or digestive tract, some have pointed out other uses, such as in oil pipelines and plumbing. Smaller than a grain of sand, these nanobots are so tiny they can literally float in the air and could potentially be used to measure atmospheric properties. What really sets these nanobots apart, however, is that they are designed to be controllable. While other devices can match these nanobots in size, they rely on the flowing of liquids and air to move. The MIT researchers are specifically looking at ways to make their nanobots more mobile, such as by adding tail-like flagella. These nanobots are also self-powered. Using a tiny semiconductor, a small jolt of electricity powers the robot's miniature circuits. Regarding these nanobots, one thing's for sure: should they turn out successful, biotechnology will never be the same. That's all we have for you today, folks, and thank you all for watching. Tell us in the comments down below what you think the top 10 micro robot is, and if you liked our video, please click like, subscribe, and don't forget to hit the notification bell so you don't miss out on all our latest content.